Hope you have your guided notes page. This one is on constant rate of change. So we've been talking about rates a lot this unit. Now we're going to talk about something a little more specific using our rates, which is something called the constant rate of change. So title's already there in your notes. Go ahead and put your learning target, 7RP2. I can calculate the rate of change given a data table or graph. So first part is some vocabulary. The rate of change is the rate that describes how one quantity changes in relationship to another. So get that definition in there. So it's how much is it changing? So something like this one here, the lines of code and the cost. So what it would cost to pay somebody to write some lines of code for a computer program or a software program. What we're going to look for is how does it change, the rate of change. So instead of looking at the numbers, we want to look at how do the numbers change. So the top line, the lines of code, went from 50 to 100. So that's a change of 50. From 100 to 150. Well, that's another 50. And then 150 to 200 is another 50. So it changed at a constant rate of 50. Down here for the cost, it was $1,000, went up to $2,000. So it went up by 1,000. Then it went from 2,000 to 3,000. So it went up by 1,000. Sorry, I should be paying more attention. Then it went from 3 to 4,000, so it went up by 1,000. So a proportional relationship, one which graphs as a straight line that we talked about in a previous lesson, has something called a constant rate of change. Each quantity changes by the same amount every time. So lines of code went up by an equal amount each time, and the cost went up by an equal amount each time. It stayed proportional all the way. It was a constant rate of change. So we can calculate the rate of change or the constant rate of change using a data table. First, start by making sure the data increases or decreases by the same amount each time. So kind of think about the steps. Here, the number of cars washed increased by 5, and then it went up by another 5, and then it went up by another 5. So it increased at a nice equal rate. Then we come over here. 40 up to 80. So it went up by 40. Then it went up by another 40. And it went up by another 40. What we do is we look for that equal or that consistent change each step for each one of our quantities. Then we go ahead and find the unit rate using that change. So in this case, we take our $40 over 5 cars, and we turn it into a unit rate. $40 for 5 cars. To make it a unit rate, we always divide by our denominator, and we get a constant rate of change of $8 per car. That means the data is increasing at a consistent rate of $8 for every additional car that they wash. Simple as that. Look for that consistent change, then use that data to find your unit rate. That unit rate is your constant rate of change. So let's try this one. This one shows the number of students that buses can transport. Again, look to see how the data is changing and if it's consistent. So from here to here, it went up by 1. Then from here to here, it went up by 1. And from here to here, it went up by 1. Down here, this one might be a little tougher to find, but you can check with a calculator. We can do some quick subtraction. To get from 144 up to 216, it would change by 72. Then from 216 up to 288, it would change by another 72. And you can check with that with your calculator if you needed to. And 288 up to 360 would be a change of 72. Now it's a nice consistent change for each one of them. So now we go ahead and we write it as a rate. We're going to take 72 students over 1 bus, because it was changing by 1 for the number of buses. This is already written as a unit rate because we have a denominator of 1. We know how much it is per bus. So this is our constant rate of change, 72 students per bus. We can do the same thing using a graph. But here's the important part, and this is going to go a long way towards doing well in 8th grade when you start to do a lot of this with your graphs and your lines. Always put the vertical change the y, over the horizontal change x. But it's the same as our data table. We're looking at how does the data change in between points. We're looking for a nice consistent change as we're going up. So this one is comparing distances traveled versus time on a highway. So our first point down here, they have it as 0, 0. Then it goes up to 1 and 60, 2 and 120, 3 and 180. So let's look at the y's change. So that's our second number. So it went up from 0 up to 60. So it went up by 60. Then it went from 60 to 120. That's another change of 60. Then 120 to 180. That'd be another change of 60. So we have a nice consistent change of 60 miles because we're counting by miles as we went up. Now let's do the same going in the other direction. Let's look at our x's. So x is our first number in our coordinates. So we went from a 0 up to a 1. So that's a change of 1. Then we went from a 1 to a 2. That's another change of a 1. And they went from a 2 to a 3. Another change of 1. So it's a nice consistent 1. This time we're talking about hours, so 1 hour. Again, make it into a unit rate. In this case, it's already a unit rate. We have a denominator of 1. So our constant rate of change, think of it as the unit rate for our change in the data, is 60 miles per hour. Last part down here, we got to answer 2 questions. Explain what the point 0, 0 means. Well, think about the actual data. 0 hours, 0 miles. So this meant they went 0 miles in 0 hours. It takes those coordinates and actually puts some real information tied to it. What is it actually talking about in real terms? The point 1 and 60. So look at 1 and 60. A 1 on the x, a 60 on the y. So 60 miles in 1 hour. They traveled 60 miles in 1 hour. That's what that data, that's what those points represent. They're representing real measurements. So last one, and then we're all done. Ramona and Josh earned money by babysitting. The amount earned for one evening are shown in the table and graph. Who charged more per hour? And then we got to explain how do we know. So basically, we're going to practice each of them. Pull the data from a table, pull the data from a graph, showing our work, and then compare the two together. So first, look for that consistent change. So the time, it went up by 1, and it went up by 1, so nice and even. The earnings went from 18 up to 27. That's an increase of $9. And it went up again, and that's another $9. So we have a nice, neat increase of $9 over 1 hour. So it's going up by 1 hour and by $9 each time. It's already a unit rate, so we don't have to do anything else. Over here, we got to work a little bit. Now I got to look at each of our data points. So they worked for 0 hours and made $0. They worked for 1 hour and made $10, 2 hours and $20, 3 hours and $30. So first we look at the change in y. So it went from 0 up to 10. So that's an increase of 10. Then it went from 10 up to 20. So it went up by 10 again. And then from 20 up to 30, it's 10 again. And my guess is if we kept going, it'd go up to 40. So that change in y, that vertical change, is a change of $10. Along the bottom, they're going from 0 to 1. That's a change of 1. Then from 1 to 2, that's another change of 1. 2 to 3, so a nice even increment of 1 hour along the bottom. And again, it's already a unit rate, so we're good. We don't have to do any dividing here. So Josh was earning $10 per hour. Ramona was earning $9 an hour. So who charged more per hour? Josh charged $10 an hour, while Ramona charged $9 an hour. So we know that Josh charged more per hour. But that tells somebody that you actually know what this constant rate of change means and what it's actually measuring. How does it apply to the problem that we were working on? All right, we're all done.